So just a reminder of the fact that so Friday we did your quiz. I'm hoping to get that back to you by Thursday. Yeah, by Thursday, and then if not, it'll be as soon as I can. And then Thursday last week we talked about linear inequality systems like this one, and we talked about absolute value equations, which we'll continue today. Before that, we had done all that solving, and that's what your quiz was on. Well, solving and writing equations as well. So that's kind of what this has in it. If you read carefully, we have two main variables. We have time spent mowing lawns and time spent walking dogs. And anytime you have a story, I would definitely recommend using a variable that represents clearly what each piece is. So like M for mowing, maybe W for dogs or walking dogs. Or you could do D and L for lawns and dogs. Okay, so this first one, it says $20 per hour for mowing and $10 per hour for walking. Of course, we're adding the total money together. And he wants that to be at least 200. So at least is what we usually say greater than or equal to. So there's one system. And then the next set is talking about his time. So now we have a time constraint. We call this side, this part, a boundary condition or a constraint that says, hey, I need at least $200. And now the second constraint is going to be maximum of 20 hours per week. So that's at least, or excuse me, no more than 20 hours per week. So now we have to do time. In this case, we just peel the variables because that's what the variables represent is time. So M plus W has to be less than or equal to 20 hours. So again, this often happens. We have like a money constraint, and then this is a time constraint. And I think you guys could probably relate to those, right? You have so many hours in a week that you have available to work, but you need at least X amount of dollars maybe to pay your insurance or your gas or food or whatever you're paying for. And a lot of what we do in our brains is what we call optimization. How can I make that the best combination of time and money that I can, right? And of course that's why you're here, partially why you're in high school, is so that the ratio of money to time gets higher. If you don't graduate high school, you don't have as good a chance to make any decent money. And then the same is said for college. You graduate college, pretty much you're guaranteed more money per hour than if you don't, okay? On average. Not that every person in America is making more money because they went to college, but on average, it's just better, okay? You get better jobs, better pay, and your time spent is more worth it. Okay. We have this last little condition that says he must spend at least 5 hours per week walking dogs. So how do we write that one now that you kind of know where we're going with this? What's that last? I need one more of these inequalities to show that one. What would it look like?
Plus 5W has to be less than or equal to 20.
This time, well, okay, so we have the 21. I'm talking about just this part. So this one is at least 5, right? Just the walking specifically has to be at least 5, which makes sense. Like dogs need to be walked. You can't say, well, I don't really want to do that. They don't pay as well, so I'll only do that for 30 minutes. Like that doesn't work. You have to get those dogs out there and walk. Otherwise, you probably get fired, and then you don't have that income either. Okay, so there's 3 systems. This is now we're ready to go solve this system by how? Like what do we do to solve a system of inequalities? Because remember, if you don't look it up, you all have access to the tools that you need. So look it up. How do we solve systems of inequalities? Whether it's just plain or in a context like this one.
Yeah, we just graph them.
Yeah, we need to graph these. So is there a clear variable that is our x or y variable? Meaning dependent, well, let me say it in order. So independent versus dependent. Is one of these more so than the other? You know, thinking x, y. Usually y is the dependent variable. It depends on what we put in for x. But does mowing and walking, are there clear dependent versus independent? No. So in this case, just pick one of them and choose it to be your y variable. So which one do you want to pick?
W.
Okay, thank you for volunteering. No clear y variable, so pick one, and he's picking w. So pick one. Okay, so we're going to get, and the reason I'm asking is because we need these two to be graphable. They're not currently, unless we use intercept. So the first one, equation 1, we need to get into graphable form. How do we do that? Let me write it down here again while you think about it. How do we get this to where w is by itself so we can graph it on our graph?
Subtract 20.
Okay, we'll subtract 20m. Our goal again is to get this w by itself. Can I combine these? Okay, and then what? Divide by 10, we got to get that w. And then we said in our notes, divide everything, right? We don't want to miss something. So now we have w is greater than 20, 200 divided by 10, minus 20 divided by 10, which is just 2. Okay, so there's one of these that's ready to go. This one is already ready to go, so I'm going to circle it and say it's good to go. And then the blue one we need to do, and it's super easy because there are no coefficients. So we just get w by itself, we subtract m. You guys remembering this? Okay, so there's our three now graphable equations with w as the dependent variable. What are we looking for to know where to recommend to this person how many hours to spend? You guys remember? What was it?
Everything that's in the same space.
Yeah, so same space where they all overlap, right? And we're only going to shade that region, otherwise it just kind of gets messy. So let's do the easy one first. It was right up there. It said w is greater than or equal to 5. So 1, 2, 3, 4, 5. And is this solid or dashed line? Solid. And is it going to go, am I going to shade right or left of that? It's this one. I'm talking about this one right here. Is this right or left of, except for I should have done it the other way, sorry. My bad. 1, 2, 3, 4, 5. That is horizontal. Probably doesn't look like it. So above or below? Sorry about the mix-up. That's going to be above. So everything we're going to shade is going to be up here. All right, let's do the purple one next. Where does this one start? It starts like on the y-axis. Where does it start?
20.
At 20. So I'm just going to put it 20 because my graph's going to be too big otherwise. Now what's the slope? Yep, so it's going down, something like that. How about this one? It also starts at 20, and what's its slope? -1, so it's going to be less steep. Okay, so then we go look, okay, we're above purple, below blue, and above red. I don't want to scroll again, but that's this little region right here. So as long as this person stays within those boundaries, and we could go find the points of intersection. We know that one is at 20, but we could find those points as well just by setting these equal to each other. So if we set purple equal to 5, stick a 5 right there. Or if we set blue equal to 5 and solve, we could figure out those boundary conditions and say, all right, don't walk the dog any more than this line, right? Don't mow, I guess. guess, any more or any less than that line. And it kind of frames this picture of, hey, this is about how much you can spend on each job. Nice, right? Have you guys ever, do you feel like you've ever done that? Maybe just, not this level of analysis, but have you ever had to think through something like that? Maybe it's not work, maybe it's, okay, I have homework, I have work, and I have time to hang out and have a life. And we're balancing all of that in the best way possible, right? Like, it's stuff we do every day, honestly. Did anybody get there right now in your warm-up? Anybody get that far? Okay. Could you now? Like next time? After all, what's the point of learning all this if we can't use it out there in the world, right? Which, you're at a level now in math that question becomes harder to answer with certain things. It just does. You'll feel that as we get more into Algebra 2, and you're like, when the heck am I ever going to use this? And the honest answer is you won't, unless you go to college, and you have to do it again. And then the honest answer is you won't ever again. Okay? But why do we learn it then? Think about that for a minute. All right. Go ahead and pull your notes out on absolute value. This kind you should be good at right now. If you did your homework, which I did see was a little bit weak this time. I get it. We had this quiz to study for in the weekend. Which was fine. Yeah, so it was a little bit not as good as usual. But here's the thing. If you didn't do this, I do want you to still go back and do the homework. Yes, you'll get the credit, but more so for the practice, so that you're good at it. Huh? Okay. See me after class for that. So, this kind, after doing the homework, this kind should be pretty smooth in my opinion. What do we do first? Actually, I keep asking you questions and then jumping. We put an example of this in your notes, so if you're confused, go pull this up. And we're going to put in some more examples right below it. But notice, here's our job. We have to account for both the fact that, and I'm just going to write this off to the side. Remember the absolute, if we said the absolute value of x equals 6, that could come from either the positive or the negative 6. And so that whole theory came and told us, hey, let's account for both positive and negative cases. So we end up splitting and getting two answers. But not until we get the absolute value by itself, which sometimes takes a few steps. Like this one, we had to subtract 5 and divide by 2. Once that's by itself, now we split into the positive, negative, or we could say the positive and the opposite case, right? In fact, I'm going to add that little note maybe right here. Add it to yours. Might save your skin later on. Negative is also known as opposite of. So, the reason we're writing that is if it already says a negative number, some students just leave it and they're not like, oh, I have to take the opposite of that. Okay? Anyway, split it into the opposite and the regular case and then solve like normal. So on this, what should we do first? Add 4. Keep those absolute value lines fairly big so that we can see what it is. Now what? Yeah, that says times 3 right there, so we'll just divide it off. Okay, absolute value is by itself, so now we take the opposite and the regular case. In fact, I'm gonna write it as opposite this time. And that means negative 4 on the left. And on the right side, leave it as positive 4. That's all. Opposite of 4, regular 4. Okay, and then of course from there we just solve. So this one becomes 0, and this one becomes 8. And we have two different possible answers for our inequality, or opposite value. Good? Now, what do you notice is different from that to these two? Yeah, weird, right? So if we have more than one absolute value, how do we get one by itself? Because then we'll still have the other one, maybe that's not. So these are different cases. Good, I'm glad we're raising hands, yeah.
So I'm guessing you would make two like the regular way. One, you try one side of the absolute value and get rid of the other side, and then you do another equation that's opposite. Does that make
Okay.
sense?
Yeah, I think it makes sense. Yeah, so let's put these as examples in your notes, just for more to look at. And I think this case, I'm just going to do one on each side. We're not going to write specific notes. I think you can probably follow it just fine. If not, write your own description of it. Okay, so again, we have an absolute value on either side. So we want to drop the absolute value and treat one side as the positive and opposite case. So we're going to split this, just drop off both absolute values. Actually, let's draw the arrows to split it first, because that's really what we're doing. So positive and opposite. Negative 5x plus 8 equals, how do we make this the opposite of what it is? Put negative out front of 2x minus 2. So we're dropping the absolute value, but we're saying, hey, it's the opposite of what's there. So put a negative sign out front. And now the absolute values are gone. We just solve like normal. But do be careful. How do you deal with that negative sign out front? Yeah, we distribute it, right? So negative 2x plus 2, since we distributed the negative. Maybe I'll show that. Okay, from there, combine your like terms. So I think I'll add 5x instead. Add 5x. And let's subtract 2. Combining steps there. Let me know if that needs to be more clear. And we'll get 2. Alright, the other side is the normal or the regular case. We just drop the absolute value. And it's kind of faster. How do you check these? Or can you? Because, like, I'm looking at this one thinking that looks kind of weird. Maybe that's wrong. So let's say we want to know, how would we check it? Yeah, we plug 10 sevenths here, we'll get negative 50 sevenths plus 56 sevenths, right? That's 8 as a fraction. So negative 50 plus 56 is 6 And then over here, 27 minus 14 is 6 So even though it's weird, it's correct. Yeah. The other one, 2, if we plug 2 in, it'll be okay. Try saying 6/7 like 50 times. Like, I felt like I was about to lose my tongue. Try it. Try it.
No.
I know. Just I'm not gonna do it right now. Sorry. All right. Let's do the other example. You don't want to try it, huh? That's not where I want to be. Is that why you were laughing? Is that why you were laughing?
Yeah.
Because 7 and 6. Alright, go ahead and write this one down. What do you notice about this one that's different about it than all of the rest of them? I mean, there's a more obvious thing, but a subtle thing. I want to see if you can pick up on the subtle thing. Okay. I think you see. Okay, so that's kind of the bigger deal. There's 2 absolute values on one side. What else?
They're both the same.
Yeah, so now we have 2 absolute values, but they are the same, which is good because we can treat that kind of like a like term. So here's what I mean. If we think of absolute value, here's the color. Define absolute value of x plus 2 as, I don't know, call it a. Do you see how we have a minus 2a equals 4 then? Okay, now we combine our like terms. So what is a minus 2a? Just negative 1a. Okay, let's get rid of the negative sign. Algebraically, just drop it. Okay, now we can plug this back in and we only have one absolute value. So we go back to a being absolute value of x plus 2 and solve from there. And we're back to a simple absolute value 1 where we take the opposite. And this is a good one to use the word opposite. Can you tell me why? We need to take the opposite of 4. Excuse me, of negative 4. So if you said negative, you would say, oh, it's already negative. And then you would say your positive case was positive. But opposite of negative 4 is. And then the regular version is the negative 4. Now maybe you would catch, and it would be a opposite case in this case is actually positive 4. Okay, solve these, you'll get 4 minus 2, which is 2. And then over here, negative 4 minus 2, which is negative 6. So we can do this anytime. Anytime you have a like term or a like radical, like a like square root, like absolute value, you can substitute it with a variable to do a little bit of basic algebra and then bring it back in when you're ready after you've simplified. We do that in higher level math. We call it sometimes U substitution, the letter U, and we define like here it made sense to call it A for absolute value, but in those cases we used the letter U. So we would say define this as U and substitute it in. And it allows you to bypass some difficulty by doing it on just a representative instead of the bigger picture. It's cool. Okay. Any questions on those two methods to get around some obstacles? Okay. In terms of the homework, I did not ask, and I'm going to now, if there were any questions that you would like to do. So why don't you look at that if you did it? Because we're going to go right back to those problems and do some more of them.
Can you go over 309?
Yeah. Is that from section 4?
That one's from.
I'm thinking it's from 4. Yeah. This one? Is it that one? Okay. Alright, so let's check this one and we'll use it, kind of get into our homework for today. Alright, I don't remember what the directions of these said. Solve by graph. Are these in graphable form?
Yes.
One of them. The other one I would move around a little bit. So let's get this one ready to graph. And that means we need to do what? You could add 3y, sure. Did anybody do it that way? Either way, we're going to have an extra step because of this negative sign. So I'm going to do it the way I think probably most people would. Your way is fine. So add x, don't drop your negative on the 3y. And then divide by negative 3, but what does that mean? Because we're dividing by this negative, we have to flip the inequality symbol. So we get negative 2 and plus 1/3. Remember to write it out front instead of with the x. So, okay, this needs to flip, so it's got to say less than or equal to. Anyway, now they're both ready to graph. And let's do blue maybe for this one. Where does this one start? At 1. And what's the slope? Dashed or solid? It's dashed, good. And the other one? Where does it start? -2. Slope? Yeah, it's the same, right? Same slope, I mean. Is it dashed or solid? Now, if you notice, these have the same slope, so this means they'll never cross. So where do we shade? Let's use words like above or below. So blue one, where do we shade? Above, red one, below. So this is kind of weird because we don't have any places where they're both true at the same time. In other words, they never overlap. No regions of overlap means what? Yeah. Yep, just kind of to reiterate, so we have that up there and this down here, so they never overlap. Did that help? Any other questions on the homework? Okay. Alright, so back to 2-7. 2-7. I had to do up to 451. So you can just finish off these last few. 52 to 55. Probably get those done before we leave. Any other good ones on here? You know what? Let's see. Let's do just the odd ones. So 53 and 55, and then we'll drop down here. And I don't want us to do the inequality ones. We didn't talk about them. So, alright, let's do 50, 52, 3, 4, 5. Let's just get a little bit of practice with those. And I'll zoom these so you can work on them without. Okay. Well, parallel we know means that they will never cross, which means at any given point they have to have the same, we could say trajectory, the same slope, the same direction. In other words, this track can't be going off this way, otherwise it would end up crossing, okay? But you see all these railroad ties, and if you think of those as a transversal, so let's say these are the railroad tracks, and we have a single tie being the transversal. For those lines to be parallel, all of our angle relationships that we've learned have to be true, have to hold true. So let's say we're talking about these two. And up here, that would be like here. Let's use a different color for that. Here and here. Do you see the analog there? Okay, so you come up to this track and you measure those angles. What has to be true about them? If the lines are parallel, then what has to be true about these two? What kind of angles are those? And if you need that sheet to help remind you, those are same side interior. So I'm just going to SSIA. And what is true about them? So add to 180, right? So you get your little tool and you measure, and if it's like probably on this stretch, it would just be 90 and 90, right? If it was correct. But if we were curving, I don't know how that works. The angle might not quite be 90. But they better add up to 180, otherwise the tracks aren't parallel right there, okay? Alright, let's pick a different pair. Let's say we picked that angle and that angle. So down here, let's say this angle and this angle. Now what should we measure? What kind of angles are those? Those are alternate interior. What's true about them? Yeah, they better be. Otherwise these tracks are not parallel. So basically what we've done is read our proof, all of our statements kind of backwards to prove these lines parallel. So here's what I mean. Before we said if two lines are parallel, then alternate interior angles are congruent. If the lines are parallel. Okay, but now we're going to say if those angles are congruent, then the lines must be parallel. You see the difference? And so what we're about to get into is both types of proof. Maybe I tell you, maybe it's in the given that these lines are parallel, and I ask you to prove some angle relationship using what you know. Or maybe I don't tell you the lines are parallel, but I tell you that these, or give you a way to prove that these two yellow angles are congruent, and then you can say, oh, the lines must be parallel because those angles are congruent, and they're supposed to be. Okay? You see kind of the two different approaches. In your packet, I don't want you to do them yet, but look at the first view. By the way, this on here, just make note on the very first one, that black, it looks like a black rectangle. I'll say this when we get back so it's more coherent. So go ahead and